Welcome to CS Beginner Bits tutorial on memory and pointers in C++. Pointers can be a tricky subject for people learning how to program in C++, but once you learn how to use pointers, you can use them to create dynamic arrays and other things that deal with the manipulation of memory. Before we talk about pointers, we'll go over the basics of memory and how data is stored. Then we'll go over reference and deference operations, which are essential to declaring and using pointers in a C++ program. Finally, I'll go over what you can and can't do with pointers. I'll try to also clear up some misunderstandings people might have about pointers. The best way to learn about pointers, of course, is to try some of the examples in this video and to see how they work in your programs. The smallest unit of information that a computer can process is the binary digit, or bit for short. A bit can only hold one value at a time, but in potentiality, it can represent two different values, 0 and 1. One measly bit is practically useless for storing information, but with each additional bit, you get twice as many possible values. Thus, the storage capacity increases exponentially. A byte, which is a sequence of 8 bits, can hold 256 values. In general, computers deal with bytes instead of bits as their smallest units because it's more relevant to human purposes. A character is typically 1 byte, and a single memory cell in your main memory is usually 1 byte as well. A variable can be thought of as the allocation of memory space to holding a certain piece of data. Each time you declare a variable in a program, you're telling the computer to carve out a space just for that variable. The size of the space you carve out depends on the data type of that variable. An int variable is 4 bytes, a float is also 4 bytes, and a char is 1 byte, since there is a lot less potential characters than potential numerics. If you're interested in finding out how many bytes are in a variable, you can use the size of function to give you the sizes of each data type. Size of works for arrays as well. Locations in main memory are identified by a unique address. If we declare an integer variable, for example, a certain place in memory will be designated to it. If we assign the value 5 to int num, the value will be stored at the address allocated to num. And whenever you see out num, you can see the contents of whatever's stored at that address. A pointer is a variable that stores a memory address of another variable. Instead of storing things like 5 or milk or other things like that, this stores a real address inside the main memory. So you can see that in this little picture, P is the pointer, and K is the normal variable, and P is pointing to K. So it's storing K's address, where P is located in memory. If we want to see where int K, for example, is located in memory, we will need the reference operator, which is denoted by the ampersand symbol. Whenever we place the reference operator in front of a variable, we get its memory address instead of the value that lives at that address. So to declare a pointer, you will need to assign the same data type as a variable whose address you want to store. An asterisk in front of the variable is called a deference operator. This deference operator makes the pointer display the value stored at the memory location held inside of that variable, inside the pointer variable. So it's kind of hard to explain, so let me show you a little example I imagined involving wormholes. Okay, let's say int num is a variable located at the address 1234. The value in num is 5. P is a pointer that holds the address of num wherever it lives in memory. Let's pretend that P lives right next door at 1235. Whenever you put the deference operator in front of P, you're telling the computer to go to that address 1234 and see what lives there. So you obtain the value stored in num without ever having to mention num. It's almost as if you're stealing num's identity, or going through a wormhole and stealing its value. Here are some potential mistakes you might make as you try to learn how to use pointers. So, a pointer variable cannot be the same name as the variable it points to. That is because the pointer needs its own space in memory to hold its own value, which is a memory address. Another mistake involves the assignment statement. Only memory addresses can be stored in the pointer. The data type you assign to a pointer isn't its actual data type, but the data type of the variable the pointer refers to. You have to use the reference operator. The misconception is that P and star P are the same variable. If you see out each one, you will see that they don't give you the same value. So, which is the actual variable? Which one actually has a place in memory? It's P by itself. Star P has no allocation in memory, because star P is just an operation. So you might be wondering, if the pointer is a real variable, can a pointer point to a pointer? The answer is yes, but it requires some special syntax. Each time you defer to another pointer, you have to add another asterisk symbol. And that concludes our lesson.